First off, let's discuss how the bootloader works and how partitioning works. So again, normally we'll take, I'll draw the spinning cylinder here, even though with SSDs it's really the same concept. We have what's called a master boot record. So the master boot record resides usually in the very beginning, the very first part of your disk, and there'll be some bootloader code there. And then there's a room in here for a record, which we'll look at in depth, that will tell us about how many partitions we have, where they start and where they end. So again, it's going to be very important because even though the operating system might only see one partition, there could be other partitions either hidden or just left over, and so on. So again, so what is a partition? So let's go some basic disk geometry here. Again, it's taking a start and end sectors and creating a sort of formatted area. In this case, let's say NTFS for the operating system to use. Now, of course, the operating system itself will be on a partition. So again, we might be able to identify the number of operating systems we have as part of this. And again, there are tools that are going to help you identify this. So what this is really meant to do is boil you down to how it identifies, what it looks at. Don't want you just to jump in and run a tool and then see what outputs, how you know what it's outputting. So you know how it works at least from the back end. So again, several partitions. We'll have a FAT partition here and so on. And maybe we have a hidden ext4. Maybe we have a bootable Linux partition. So again, partitioning is pretty basic. Let's talk about disk layout also. Disks are typically laid out. We have tracks, and then we have our sectors here. And then we also have what's called blocks. So sometimes referred to as clusters, but a block itself will have a set size, 512K, maybe 1024, that's a 24 there, or even 2048K. And this is going to depend upon when partition was created, either by the operating system or by an individual. So this size is where files are stored. So if it's 512K block size and the file is 1024, it's going to take 2 blocks. If the file is slightly larger than, let's say the file is, 124K. So it's somewhere between here, right? It's not exactly 2 blocks. So what you have is, 2.5 blocks for it. And the rest of it is either filled with zeros or it's called either it's remaining zeros a lot of times, or it could be memory slack that's filled in here. So the idea is if the file doesn't take up all of it, it does take up that whole sector though. So again, we have these sectors, and these a lot of times referred to as clusters. And what we have is file allocation tables, or our FAT table. Our FAT table is going to tell us where a file starts, what sector, and what cluster, and then in there is written metadata about the file when it was accessed, and then it will tell us where the next one is, and the next one is, and so on. Now, these are not usually contiguous. To be honest, with spinning disks, you're never going to have a file that's very often written contiguously along those blocks. As the read-write head touches it, it's going to write maybe a part of it here, and a part of it here, and a part of it here, and so on. Now there's a whole nother level here I'm not going to get into with NTFS, ext4, and so on. You have journaling, and inodes, master, and I don't want to get into that level, but just keep it here for now and understand what a partition is and how we can look at it. So how can we look at a partition itself here? So if we were to dump our drive information to a hex editor, we have what's called a master boot record. And it's means you can have a starting byte That's what the side here is. This is the offset in bytes. You can see you start at 0 and you work up, and it is hexadecimal. And then you can change your settings for this. But the byte, this will change on the different disks. But a lot of times it's like 1 BE, I believe. So 0x1 BE is where we might see the start of our master boot record. You can always verify with the type of the disk you're looking at, but typically you'll see it here. This is actually the boot code. This is your bootloader right here. So it's like the first 442 bytes or so are filled with bootloader, and then we have here is the master boot record. This is going to get some information about our disk. So that's what the lab this week does. I just want to sort of summarize what the lab is, what the lab's sort of coming across with. So again, you can see here on the textbook, there are tools to do this. Sigfind, what kind of partition, and here we have a DD image, and it's going to tell you the file signature, the signature, the number of blocks, sectors, and so on. In this case, how many operating systems there is, if there's any, more than one. Again, I'm not going to read the book to you, but that's basically what we're looking at, is partitioning and disks. There's other stuff here about journaling tools and so on, but really this is probably the heart of it here, is partition identification and recovery. So this master boot record, how do we look at this? So the master boot record is 16 bytes, and it is broken out into separate sections. So here you can see I've written out a sort of basic master boot record, and we're going to walk through it here real quick, do it the best we can. So byte 0, it's going to be either a 80 or in this case a 00. 80 means it's active, 00 means it's inactive. So this is an inactive boot record. But that's what the first byte, or byte 0, indicator. So it's a flag. A lot of times it's called a flag sometimes. It's either one or the other. So 80 for active, inactive is 00. So bytes 1 through 3 is our starter partition. Byte 4 is our partition type. In this case, it's 83. This is a pretty important one. This is one you'll want to pull out and identify, and I believe you do this in the labs. And there are partition type tables you look at. In this case, this is just a wiki page. The lab has one for you. You can see there are all types. Swap spaces. You have, this case tells you the occurrence where you find this flag, the master boot record, or extended boot records. But if you go down here and you find 83, we see that it is a Linux partition. Any native Linux file system uses an 83 as its file system type. So you can see you have stuff for OS2, different operating systems have different types, NetWare. But of course the main ones are going to be your FAT32, of course NTFS, and so on, VFAT probably. But there are a lot of them. So that indicator is very important to help you identify what type of system we're dealing with. In this case, it's Linux. So pretty important by there is byte number 4, partition type. 5 through 7 here is our end of partition indicator. It's going to be the locations of our start and end of partitions. And now we come up to what's called a logical block address. This is bytes 8 through 12. And again we have, and then, yeah, 8 through 12, yeah, 8, 9, 10, and 12. So, as we walk through this here, let's look at the just start of a partition. This is going to break out into our drive, our cylinder, our sector, and so on. This is going to break out into basically our drive coordinates. Think of it this way. There's information here about where it starts, what sector, what track, and so on. That's what that holds. So as well as the inner partition. This is going to be the information about our cylinder, header, and so on. So this is going to give us this sort of coordinates where the start and end is and the type it is. So very important to understand what those are. Again, this is a summary video, so I'm not going to get into the math of this here. You should be able to find that if need be. But a lot of times it's really more I just want to understand what those bytes are for. So now logical block address, LBAs. Our logical block address are going to tell us about our partition table. So this is our partition table, and it's going to tell us where it is. So in this case, this is written in Little Endian, so it'd be 00000003F. So again, Little Endian, very important. This is discussed in a different video about hexadecimal. So it's 3F. And this is where we indeed find our FAT boot sector. So our FAT table, our file allocation table. It could be very important to find where that's at, because that will then identify where files are at. Or our tools will at least discover this and say, okay, this is the location of our FAT table. Go there, and then it can identify both current active files, even deleted files. It can maybe search through ones that were marked as deleted and see what was there. So I'm not going to go through the partition table example there, but we do have here is, of course, our the inner partition table. We have also the number of sectors. So this is going to tell us the number of sectors for our LBA here, a logical block address for our partition table, number of sectors that this FAT table is, how large it is, so where it starts and how big is it. Now again, this is written in Little Endian, so if we do this 0001 39 86, so those last 4 bytes there. If you break this down here, this comes out to being 80,262. That's what the size is. We break it into decimal, and that's the number of sectors. So again, if you look at our thing here, we have sectors. These sectors are going to tell us, so we know where our FAT begins. Let's clear this off here. So again, if we look at our disk, our master boot record, we have our bootloader code, and then we have those 16 bytes of our master boot record. It's going to tell us our partitions, where it starts and where it ends. Let's just say it's one partition. We'll keep it simple for now. Where it starts and where it ends. The type. Is it FAT32 NTFS? Again, a partition table, which you find a lot of these in reference, will tell us what it is. And then it'll tell us where our FAT table starts. So where our FAT table is, maybe it's up here, our file allocation table, and how big it is. That's pretty big right there. That's a little blunt example there. Usually it's not that big, but where it started, you know, how big. So our starting address for our FAT table and how number of sectors it takes. Again, very large disks can have larger tables with more files. So pretty important point there. That is a lot of information in those first 16 bytes of that record. Now a couple of things to note here with bootloaders and our boot sectors. So important thing is that we have really 2 types of bootloaders here. We have our master boot record, which is really for our older ones. And then we have our GUID, which really is for new operating systems. Master boot record, some things about it. It's limited to We have a max of 2 terabytes of addressable disk space. Now, why is that? 2 terabyte is actually the largest 32-bit number that can be addressed. Then it has a maximum of 4 primary partitions. So a lot of times the 4th partition is called extended, and then it has the location of the other ones, and those are called logical partitions. God, if I can write with this, it would be good, wouldn't it? So again, logical partitions. Yeah, that's really good logical there, Mike. Let's erase that. Okay, keep the L for logical. So our external partition, these are our 4th partition. It's identified as extended. In there, the extended partition will have information about further partitions because you can only have room for 4. Again, you only have so much space in that master boot record, and it only has room for 4 partitions. So again, you know, even though the master boot record has information about the partitions, you know, start and end, you only have room for 4, but this is a very small space to write that to. And again, that's for the master boot records. GUIDs. So GUIDs is a GPT, a GUID partition table, also called GPT. And it has actually room for up to 8 zettabytes of disk. So look that up if you want. That's a lot. So it can have 128 primary partitions. Again, we have a 64-bit. OS usually will, most 64-bit OSs actually require a GPT. 32-bit's going to be for older operating systems. And in terms of forensics work, you might find in older laptops, older devices, or ones that use 32-bit OSs that have master boot records are being used and are part of your evidence. So I know you think, well, why we look at this old stuff? Not everyone's going to have the latest and greatest. Yes, some really old stuff for evidence, but 128 primary partitions. So there's a lot more stuff here. So just FYI how it rolls up, how we fit that information inside here. So that should wrap it up here. It's pretty quick. I have a separate video about hexadecimal. I actually made it separate on reason for purpose. There's other types of stuff to look at too. That you have other partitions you might need to think about. Just some side notes. It's not always going to be the simple just one partition with your OS. Actually, a lot of operating systems come with a recovery partition, and then we have our actual master boot record, and then we have, of course, our partitions. Maybe just one actual partition starts here, ends here, with a FAT table. But you have a recovery partition here. Macs have it, even Windows has it. They're usually pretty small. Could be used to hide data. Again, from my experience talking with the FBI, they don't really see that at all. But it's up to at least look for these hidden partitions. Someone could go in and create a partition by editing the master boot record. Again, this is some really low-level stuff. I think it's probably makes more sense for someone just to encrypt. They'll just encrypt with a real strong encryption the file, have a strong password. But again, remember we have extended partitions with our MBR. So yeah, the GUID GUID takes a new BIOS, so called UEFI. So it's the newer BIOS. So BIOS, that usually refers to master boot records. The UEFI, which is really just the BIOS, that usually refers to a GUID or a GUID partition table, GPT, or a GUID bootloader. This is the newer stuff. So one last thing to note here, I know we're drawing a round disk, and really what you look at is SSDs, solid state drives, right? More and more common. You very little. You still see spinning disks, and you might have those definitely as backup devices. But SSDs are really becoming more common. An SSD is not a spinning drive, of course. It is a set of memory cells that are basically the grid. There's some differences with SSDs because of wear leveling, how data is written to it. But a lot of times still, the very first logical block is usually where your boot loader will start, your master boot record, or GUID or whatever will start usually at the very first part. But how stuff is written is a little different. So there is a video, I think, already located that goes into great detail about SSDs. And I won't go through that here. That's actually been referenced as part of the course material. So really in depth, really good. Again, the idea is I want to bring this back up to the summary level. This is an introduction to digital forensics. You're like, well, you're going to be manually doing this? You're going to manually go through and compute this manually? Probably not. But at least now, if you do look at a master boot record, and you can see, you count, okay, 1, 2, 3, you count in so many times, okay, to the 4th byte, it's type IE3, you know at least immediately where to go look for that, and you know the tools you're using that are going to do this for you, what they're doing under the hood. It's going to make you a smarter forensic analyst. You need to understand how these inner workings are happening. But again, in reality, because of time, and we have tools to do this for us, tools to extract this data, and tools to tell us exactly what it is. You can see this example here of SIGFIND is going to actually tell you it's a DOS partition and there's a hex value 55AA. So, but now you know where that came from. So